Alright, this lesson is to refresh your memory on how to simplify radical expressions. Um, so before you do any adding, subtracting, multiplying, or dividing radical expressions, if you forgot how to do some of this, this will be the first video and lesson you'd want to look at. So let's take a look at the first problem right here, example, and kind of go over a few things. Um, when we look at the radical, uh, and there's usually going to be a number right here. But if there's no number there, that means we should know that this is the square root. Or there's a 2 there, that's usually, we never write it. It's like, do we write 1x? No, we usually just write it as x. So when it comes to square root, there is a 2 that belongs there. If you look at a calculator, there's usually like an x radical symbol that you'll see. And that x represents whichever number you want to plug in. So if there's a 3, that would be the cube root. 4 would be fourth root, etc. So when I take a look at this right here, some other things is that this is the radical. And then whatever number happens to be inside of the radical, we actually call that the radicand. Okay, so radicand. That's whatever would be inside of the radical. So as we take a look at this problem, remember, you have to think, what number can I square for to equal 4? That's pretty much the easiest way to think about this, and that number would be 2. Because if I take 2 and I square it, then that would equal 4. So square rooting and squaring a number, they're not the same thing. I see students a lot of times, they'll say both things uh, interchangeably, but they are completely different. Okay, so make sure you use your terms correctly here. As we move down to this next problem right here, uh, radicals are not always easy. It's not always perfect squares, right? So if you know your perfect square factors, like 4, because that's 2 squared, 3 squared is 9, 4 squared 16, 5 squared 25, etc., then things get a lot easier. It gets a little more challenging when we take a look at the second example, because 75 is not a perfect square. So you have to think of what are some factors that are perfect squares here. Well, what I can do is take this number, 75, and multiply it, or get two factors, the 25 and 3, and I chose 25 because that happens to be a perfect square. So 25 times 3 equals 75. When we put it all together, the square root of 25 is 5, and then we can't square root 3, so that's our answer right there, 5 rad 3. Okay. Moving along. This is where there's a little more thought that needs to be taken place when we start dealing with radicals. Okay, so we have to think right here, what number can I, or what variable can I square to get me x squared? Now, in Algebra 1, you've probably learned that you could take this right here, and you could rewrite it as x squared. And then when you square root something, that is actually raising it to the 1/2 power. So you're saying, where does the 1/2 come from? It comes from our radical and what the root is, and then we put it over 1, because right here, essentially we would take this and put it over 1 to the first power. So if you remember, if you raise a power to a power, one of those multiplying rules for exponents, you're actually going to, well, when you raise a power to a power, you multiply the powers. Meaning you're going to take this 2 and multiply it by 1/2, and that equals 1. So bottom line right here, what this equals is going to be 1. Okay, so we take x squared and we raise that to the 1/2 power, that's going to equal 1 or just x by itself. So the rule right here that you could simply use is if you do take the square root of something and you take the square root of a power, you go ahead and divide it by 2 and then you can be able to get your answer. Okay? That only works, however, for even exponents. So if that was x to the third, that wouldn't work, and then I would have to show you another step in between. Now, with our answer right here, we are almost there, but this is actually not the right answer or the final answer. Think about this. If I have, what we're saying is that x, if I take the square root of x squared, that's supposed to equal x. So that's going to be true a lot of times. So if I take right here, for example, I plug in 1, I square it, that's going to be 1. The square root of 1 is equal to 1, right? That works out. That's true. If I said x is equal to 2, okay, let's try that again. I plug in 2 right here, I square it. Does that equal 2? Sure does, because 2 squared is 4. The square root of 4 is 2. But what happens if I have a negative number? So let's try this. If I have negative 1 and for x, does that equal negative 1 as my outcome? Which is what we're saying the answer is right here. Negative 1 squared is 1. The square root of 1 is 1. That does not equal negative 1. So we realize that that doesn't work out. So what do we do? In order for us to get the right answer, in this instance, we have to put the absolute value outside of the variable. So when do we have to do this? Okay. When we take this step is when right here our exponent is even, but when I get my answer, my exponent is now odd. That's the only time you're going to have to do this. So once again, if my exponent right here is even, but in my answer, my exponent is odd. Or sorry, yeah, and that would be 1 if it's just x. So that's the only time you're going to have to do this. You don't have to do it all the time. So for example, if I take this x to the 4th, or I said if we're square rooting an even power or exponent, then we're just going to divide it by 2, and this is x squared. And that would be your answer. You don't have to put the absolute value right there because it is an even power. Because remember, when you take a negative number and you raise it to an even power, it's going to stay positive. But if it's an odd exponent, it's not going to stay positive. It'll remain negative. So that's why it only has to happen when we have an even exponent and then when your answer becomes an odd exponent. And I would say that's one of the big takeaways for this lesson. So right here on number 4, we have ourselves an odd power, x to the 3rd. So what we're going to do is pretty similar to what we did on the first few questions on 1 and 2. And what I'm going to do is make this into an even exponent. So I have x squared times x. These two factors get me x to the 3rd. And so what I have to do now is go ahead and I can take the square root of x squared, divide that exponent by 2, and that'll get me x. So right here, this will become x rad x as my simplified answer. You may ask, why didn't I put the absolute value around the x on the outside? Well, remember, initially on my problem, we were dealing with x to the 3rd power, which is an odd exponent. So it's not going to be necessary to put the absolute value because it wasn't originally an even power. So that's why I didn't put the absolute value around this x. So on number 5 right here, we got x to the 4th power. Remember, when we're square rooting, we take the exponent divided by 2 or multiply it by 1/2. And so this will become x to the 2nd. Hopefully there's something you need to add, and there should be, because remember, uh, or actually there's nothing, because remember we have an even exponent. It remained even, so we can go ahead and leave that as x to the 2nd power. So now let's take a look at number 6. We have x to the 5th. When we go ahead and split this apart, remember we can't divide 5 by 2. That gets us an improper fraction. So what we do is we go ahead and separate it with x to the 4th times x. Now, I can't take the square root of x, but I can take the square root of x to the 4th. And that gets us, remember, take the exponent divided by 2, and we get x squared rad x. Right. And now let's take a look at our last example right here. Number 7. Let's see what happens. We have x to the 6th. Remember, we are square rooting it, so we take the exponent divided by 2, and I'm left with x to the 3rd. Let's go ahead, put our absolute value, and then you will have the right answer. Okay, you could put it actually right here, like how I wrote it, or probably what you'll see actually more often is we'll put the absolute value around the x and then to the 3rd power. Because remember, we had an even exponent. When I square rooted it, it became odd right here. So there you go, the ABCs of simplifying radical expressions.